This video will cover rigid body dynamics with motion capture. It will build upon our last video of motion capture workflow, from Blender to CC4 to iclone 8, and back to Blender Octane for rendering. We will add a rigid body table breaking from a thrown character landing on it. Let's open up the coffee table from our last video. We want to pre-break this table with the Cell Fracture plugin, which will be covered later. For now, let's add a second material to slot 2. This second material will be applied to the newly generated surface polygon after using Cell Fracture. Activate the Cell Fracture plugin by going to Edit, Preferences, then search for Cell Fracture and click the activation button. Cell Fracture is located in Objects, Quick Effects. We are going to use the particle system to define points for use in Cell Fracture. Setting the end frame to match the starting frame will allow all the particles to appear at once. Reduce the size of the particles by going to the viewport display and changing the size parameter. Let's activate Cell Fracture. I'm changing the first parameter of scale to a smaller number. This should help me create a long wood splinter look. After the splinter, new interior polygon surfaces will be created. We will assign material 1 to those new surfaces. Remember, the material 0 is slot 1 and material 1 is slot 2 of the material list. You can move all the new Cell Fracture geometry into a defined collection. The polygon might shimmer as it is displaying both the original geometry with the new fracture geometry. Let's hide the original. Apply Cell Fracture to the rest of the table. Drop in the ground plane and apply rigid body with type set to passive. Give the ground some thickness. This will help the table dynamics from penetrating the floor. Select a collection with all the fracture geometry. Then select all the objects within. Apply rigid body and make sure the type is set to active. Passive is generally for objects that don't move. Apply your desired friction amount. With everything still selected, apply the settings from the active selection to all selections. Go to Object, Rigid Body, and copy from Active. Set the frame range so that the simulation doesn't need to calculate needless frames. Hit play to run the simulation. After the first slow calculated playthrough, it should run faster on the next loop. Next, we want the pieces to stick together until there's enough force to break it up. We need to constrain the pieces together. With all the fracture table pieces together, go to Objects, Rigid Body, and Connect. Use Chain by Distance. Hit play to run the simulation, and you will see the table break, but clumps of pieces are still held together. Let's organize the outline by putting all the constraints in a collection. Now with all the constraints selected, we will make the constraints breakable with an apply force. Check breakable, then right-click it and select Copy to Selected. This will apply the setting to all selections. Now change the threshold parameter to 0, so any force will break the pieces away from the constraint cluster. Copy it to all selections. The deactivation parameter prevents the table from falling until a linear or angular force is exerted. To test this, let's create a ball to drop on the table. Create a UV sphere and shrink it down. Move the sphere above the table. Apply a rigid body dynamic and hit play to run the simulation. Change the friction to 0.9 and increase the ball's mass to 10 kg and rerun the simulation. Still feels a little light to me. I'm going to play around with the mass and bounce parameters. You can now delete the ball, and we'll stop here for this video. The next video will cover importing the mocap character and getting it to interact with this table. If you like this video, I would appreciate a like and a sub. Until next time.